Hey everyone, welcome back to my channel EduVibe. In today's lesson, we're moving to the next topic of the Unit D, which is the last unit of the grade 11 chemistry. We are doing the gravimetry stoichiometry. Basically, we start with the stoichiometry things. We're doing the three stoichiometrics. This is the first one, and in this, we are basically doing the stoichiometry when we're doing the irrations, and when we have one thing in the irration, we'll find another thing. So that's called the gravimetry stoichiometry. In this, we are basically focused on to the moles one. I already did the volume one when the volume is given for the one thing. I have to find another one. We also done for the concentration in the previous unit. Now we're doing for the moles, but this is called the stoichiometry thing. So what is a stoichiometry? So stoichiometry is a description of the relatively quantities of the reactants and the products in a chemical reaction by the chemical amount. So they are the relative quantities. They are the description of the quantities of the reactant side and the products in a chemical reaction by the chemical amount. Chemical amount is called the N, which is the number of the moles. Then in stoichiometry, the following reaction assumptions are made. We can make the four of the assumptions when we're doing any stoichiometry thing. So reaction is spontaneous. Spontaneous means the reactions are very fast. When the reactants are fixed for all the examples you are given. So this is very fast reaction. Again, the reactions are very fast and be stressful was within the reasonable time. They will in the, like a very short span of time they done that reaction. They are contradictive. They are contradictive because they are more than 99% completed. They have a 99% of completion rate. So that's why they are very contradictive. And the reactions are stoichiometry because there is a simple whole number ratio of chemical amounts of the reactants products represented by the coefficient of the balanced chemical equation. We already did those things. We just recap those things in the form of other things. Like today we're doing the gravimetry stoichiometry, which is basically the simple things when we doing the coefficient things. So this involves the chemical amount calculation. So in this we're doing the chemical amount calculations. Here you can see the n required is equal to n given multiplied by the coefficient required and coefficient given. Formula stays the same. We done with the volume, we done with the concentration, and we done all things with that same formula. So these are the reaction and reactants in the chemical reaction. So how can you solve these type of questions? So firstly, you have to write a balanced chemical equation, and with the known quantities, the quantity which are given to us, we have to write those quantities. Then convert the measurement to a chemical amount. We have to get into the n. We have to find the n for that one of thing if it's not given. So then we have to calculate the chemical amount of the required substance, which is going to be a question that we have to find the chemical amount for this substance. We have to find for the this substance with the whole ratio from the balanced chemical equation as we done in the volume and concentration. Then we have to convert the calculated chemical amount to find the quantity they requested, or if they want the chemical amount, so we left over there. If they want after chemical amount something else, so we have to find those things too. So let's take to the example, and you have to know that how can you solve those things. So the question says iron can be produced by the reaction of iron third oxide from an iron ore. So with the carbon monoxide to produce iron metal and carbon dioxide. The mass of the iron third oxide is required to produce 100.0 grams of iron. So to find the mass of the iron third oxide. And this thing is the reaction with the iron, then with the carbon monoxide to get the iron and the carbon dioxide. So we have we have this one. So this is Fe3 plus, or this is O negative. So basically we have Fe2O3. This is solid plus CO, which is carbon monoxide gas, and we get Fe, which is solid, plus carbon dioxide, CO2 gas. Now our second step is to balance this. So we have a 2 over there, so we write 2 over there. So if it is 2 and we have a oxygen 2 and we have 3 oxygens over there, because we write 3 over there. So that is the final thing, and we have to find the mass for this one. And what things are given to us, so we have to write those. So the mass of the iron required to produce this much of iron. So we have a mass of the iron, which is 100.0 grams. From this, you can find the molar mass of this. So you know the molar mass of iron is 55.85 grams per mole. You can see from your formula sheet, periodic table. From here you can find the n, because you know the n is equal to the mass upon molar mass. So divide this, you get 1.79051 moles. Done. From here you can also find the molar mass of Fe2O3, which is going to be 159.7 grams per mole. This is basically the molar mass of this. And you'd find the n from here. Or you can actually find the n from here. How? So you have to find the n for this by doing this thing. So this is the required, which is 1.79051 moles, and coefficient required is 1, so it's 1 by 2, and coefficient given is 2. From here you can get about 0.89525 moles, and this is basically the n for Fe2O3. But you'll find the mass. So you have n, you have molar mass, you can find the mass. You can do in this, splitting in this. So n times molar mass. So n is 0.89525 moles, and multiply by the 159.7 grams per mole, and you will get your mass of about 142.97 grams, which is basically treats this of 143.0 grams. So this is your mass for the iron toroxide. Just the simple things. We can't use any like different formula. Just use the same formula with the terms of the n, which is a molar mass, which is a chemical amount, and we use this mainly. The n is equal to mass per molar mass. So it's an easy thing. You can find the things very easily in this, and this is type of the easy questions. One of the easy questions in this unit. So next question we have, and we have another example too. So question says 4.07 grams of copper first nitrate dissolving in 500 ml of water. The solution is then mixed with a solution of sodium sulfide. Predict the mass of the precipitate that will form. So they not given us the whole thing. They don't given us the whole thing. We have to complete that thing. So we have a copper first nitrate, which is basically the CuNO3, which is aqueous, which is dissolved now, and they have added the sodium sulfide. So sodium sulfide is Na2SO3 aqueous, which will give you, so this is a double displacement reaction, so we have to do this. So NaNO3 you will get, which is aqueous, you can check from the solubility table, and Cu2SO3 solid. How can you come to know that what is precipitate? So precipitate is a thing which is in solid. So this Cu2SO3 is a solid, so you have to find the mass for this thing. And we know the molar mass again for this, which is 207.17 grams per mole. You know how to find. So you have to find the n, but you don't have any necessary information. But you have the mass for this, which is 4.07 grams. You can find the molar mass of this, which is 12556 grams per mole. And you'll find the n of this, which is 0.032414, which is in moles. Now you can find the n of this. So n of Cu2SO3 you can find by, you can do 0.032414 moles. Coefficient required upon given, which is 1 by 2. Oh, you don't balance, we don't balance it. So this is 2 basically, and this is also 2. So I have to balance this. I forgot this. You have to balance it, and this is 1 by 2. You get the n of about 0.016273 moles from here. So this is 0.016273 moles. Now you find the mass of this. So it's easy again, as we did in previous one. Molar mass into the n. When you multiply this both thing, you will get 3.36 grams. And this is your mass for this. So they've given us the volume, but there's a not role of this volume in this question. You have to just doing the same thing as we do in the previous one. But the thing is that you have to complete this reaction first and find the precipitate thing. That's the key part in this. So you have to best into how to find the things which are soluble and not from the soluble table. If you come to know that, you will come to know that this is the solid thing, and you will get the right answer from this. Done. So that's all for this lesson, and we're done with the first geometry. Next one is the gas geometry, and this one is again connected to the one of the formula we already done in the second unit, which is the ideal gas law. So we done this already, and we are discussing this thing in the next unit, in the next lesson. So that's all for this lesson. Language to EduVibe, learn smart not harder. Please like and subscribe to my channel. If any questions, let me in the comment section. See you in the next lesson. Till listening with EduVibe.